Thanks for calling in. This is CloudBank Cloud Clinic, and we'll be talking today about kind of an interesting approach, I think, of linking an Azure subscription to a GitHub account to access GitHub paid features. My name is Scott Henderson. I'm a research scientist at the University of Washington, where I work in the Earth and Space Sciences department, and today I'm in the eScience Institute where I also work. Uh, I'm joined by Rob Fotland, who's done many of these cloud clinics in the past for CloudBank. And feel free at any point to unmute and ask questions. It's a small group, so I think we can do that. We have 45 minutes, and I have about 20 slides to go over. So I'm gonna just go ahead and go with them. But if any point you have questions, go for it. I'll also just like finish a bit early and we can ask questions then. And that discussion won't be recorded. The presentation itself will be. So that's also an option for you. All right. Let me go ahead and advance. So I'm assuming today that folks on this call have a CloudBank account. And this presentation is specific to having Azure access on that account. So we won't be talking about how to get access. It is not necessary to have an account through CloudBank. The only requirement here is that you have access to an Azure account to do this. But we'll be just focusing on how to connect that account to GitHub and how to use some features. Oops. So this is kind of a big summary slide, and I will also share links to these slides towards the end of the presentation, just in case other people are joining and miss the link. But here's kind of a big picture summary. So,
Okay, question. I'm seeing your title slide, not in presentation.
oh, okay, hold on a second. We're not getting the slides. So is that advancing?
I still see the layout.
Okay, hold on just a
It,
second,
it
everyone.
advances, but it's not in the presentation.
Okay, let's try just the full desktop.
Here we go.
It's advancing.
Presentation.
Okay. Sorry about that. Fixing the slides. So this is kind of a big picture summary. So GitHub, which is a platform for sharing code and many other things now these days, uses Azure behind the scenes for a lot of features, including their actions, which is continuous integration machines, and code spaces, which is a set of hosted virtual machines. So in a way, anyone with a GitHub account can use GitHub for cloud computing. I think this is a nice like entry point, especially for students at universities who get a bit overwhelmed potentially with all the features that cloud providers offer. Um, Often for a lot of advanced features on GitHub, you need to add a credit card to an account to pay for larger computers. An alternative, though, is to link an Azure subscription instead of a credit card. So that's the key thing today. We'll walk through how that's done and what that enables for you. Um, the uh, two kind of workflows we'll mention today are doing batch computing on GitHub Actions, so running kind of lightweight distributed computing workflows, and then also showing just their code spaces approach to run VS Code on a machine on Azure. So that's more of the interactive computing. I think it's a nice approach because using these GitHub features like GitHub Actions teaches some cloud best practices for people. It sort of forces you into a reproducible workflow that can run on different machines and helps design workflows to take advantage of ephemeral resources, which cloud computing is ideal for. Um, it also helps structure workflows around how you manage storage in terms of storing ephemeral things temporarily and then figuring out how to output longer term storage elsewhere. It does cost more to use these GitHub machines compared to configuring everything on your own through Azure. And that's pretty standard. Anytime a company is configuring machines on the base cloud provider, they tend to charge more. So it's like a per minute cost that's about 7 times more than what you would pay if you like set up everything yourself. So that's the kind of drawback worth keeping in mind. Um, if you're new to GitHub, I'm assuming folks on this call are already familiar with it, but just in brief, it is a developer platform that allows you to create, store, and manage and share your code. And GitHub Actions is their continuous integration system that allows you to automate running code on these Azure machines. My favorite definition of Instagram came from back in the day when I used to use Twitter, and this person was mentioning that for the younger generation, it sounds a lot like social media. Actually, it's just a bit nerdy. So there is that social element as well. And sharing public code, I think, is more prevalent in the academic world. Um, but essentially, a key thing here is that the actions is not just continuous integration. So this is taken verbatim from GitHub's documentation where they say you can discover, create, and share actions to perform any job you'd like, including CI/CD, combining actions to run completely customized workflows. So they're also kind of aware that it's not just for running tests in software. It can be used for many other things. And putting this a bit more into context, GitHub's existed for a long time. I don't actually know how long, but Microsoft acquired it in 2018. And you'll notice that the GitHub Actions, which is the system running on Azure, starts up pretty soon after that. So it's been around since 2018, but this payment via Azure is relatively new. So that's something that came about in 2023. And since then, it's hard to keep track of. They're continuously adding a lot of new features, and a lot of these new features are like larger machines on Azure that you can access on GitHub. So it's becoming, in my opinion, more of like a full-featured cloud portal. Is how I think about it sometimes. So how does this work? I won't walk through the full setup, but it is a setting under your GitHub account where you will go to GitHub settings, billing and licensing, payment information, and you have the option to link to your Azure subscription. And so it's a button you push, and then you just have to enter in your subscription ID, which you get in logging into your Azure account. And then GitHub walks through a confirmation to just confirm that you want to link your billing to that Azure account. And at the end of the day, you'll see on your GitHub account, so this can be, in this case, we use it for organizations, usually in GitHub. You'll see in your billing that you have all metered services are being billed through Azure. So this is great for researchers because you do not need a personal credit card. Um, Also, since this is largely an academic group, I think this is another feature that people should be aware of, which is linking your GitHub account to an educational account. This gives you access to pro features. So some of the billing, one, you need payment, but two, you also need the pro level GitHub account. But that's also free if you're affiliated with an academic organization. So, so that's worth doing as well. Basically, you have to just confirm that you work at a university or have an academic affiliation. So here's kind of an overview of all the machines that are offered.
Sorry, can I just interrupt you for a sec?
Yeah,
The
right.
education account that I'm affiliating with, Is that something that I set up or it's exists independent unto itself?
Rob was asking for a little bit of clarification on this education account. Uh, it's it's just a linking of your existing GitHub to show that you have an academic affiliation, and then that gives you GitHub has like free, pro, and enterprise level accounts, and that gives bumps you up to pro. It gives you like access to bigger machines.
Okay, so
So,
it's just like a free entry into better computing environment.
yep,
Okay,
yeah.
fantastic.
Yes. And again, I'll share a link to the slides, which has the relevant links. It can be hard to find the right page on GitHub because it is so many things these days. Um, so for these larger machines for GitHub Actions, which is their VMs for running workflows, there are a lot of options now. By default, I think you run with 4 CPUs and you have a certain number of minutes per month. And public repositories are free, but private starts hitting the metering. So you have to pay for it if your repository is private. But you also can choose these much larger machines. So for CPUs, if you're running like a scientific workflow, that maybe that's not enough. But as you can see now, you have options all the way up to a 96 core machine with quite a bit of RAM and storage. So you can run more computationally intensive workflows. And the costs, you can see here in the separate table, scale approximately linearly. So if you have workflows that take advantage of multiple cores, you can check out and run something on a 96 core machine in a fraction of the time for the same cost as waiting around for a 4 core machine to finish. So that's kind of the appeal of the cloud. You can get things done quicker for the same cost. These costs, again, just to reiterate, are a bit more expensive than the standard rates if you were to configure a machine yourself. But these machines have the full operating system ready to go, and you just have to kind of select on a radio button, and that's it. There's no additional setup. So this is my short list of desirable features of a batch computing system for academic use, and why I was initially drawn to using GitHub for batch computing. So one, no personal credit card required. Uh, we've ticked that box. You can start for free and then pay additional for speed or scaling. Um, when you're not using the system, it's scaled down to 0, so you're not incurring any costs. You have both a programmatic way of doing things, so like a CLI through the terminal or the website user interface. You can share your batch computing resources with a team. There's some sort of secrets management if you need like account tokens to access data for your computations. There should be some sort of dashboard way to view logs as computations are progressing, easy way to rerun, and some sort of like team management. So an ability to cap budgets for certain workflows. Um, and then ideally, no lock-in to a single system. So you could run on different back-end systems if you want to change where you're running that batch computing workflow. That last one, I think this does not meet. So if you're running these things on GitHub, that with Azure, that is your only option. Everything else does sort of work here. So to give some examples, this here's a project that I was involved with here at the University of Washington eScience Institute. We had a need to process thousands of satellite images, and each image processing workflow took about 10 minutes to run on a laptop. And this was sort of our first foray into using GitHub Actions to to try just using their system to do batch processing, where we farmed out these thousands of 10-minute image workflows to the GitHub Action system and ran it as a batch system. It's worked really well. I'll show a few more examples of what it looks like, but you're running 60, there are limits on like the number of concurrent jobs that are running on any given time. In this case, we're up, I think it's 60 currently. So for a group who's largely just working on laptops, this is very convenient because you're finishing things 60 times faster than you could otherwise on your laptop. Uh, I mentioned earlier, it's nice to have a programmatic way to do things. So GitHub has a command line interface, and this is what our workflow looked like. So a workflow is designed as a YAML document. That YAML document at a bare minimum maybe points to a Python script or some other code that you need to run on that machine. You can point at different repositories to run different workflow if you have scripts stored in different repositories. And then you have dynamic inputs for every workflow that you run. So in our case, I mentioned we're processing images. We point to a specific year and then a specific region of the world. And our code goes and searches for images, pulls them down onto the machine, crunches numbers, and outputs the final processed image. So that's big picture what the workflow looks like and how you might call such a workflow.
So can I just confirm then that my mindset using this is I'm never actually logging into one of these machines on a terminal, but I'm just using the command line and the configuration I've set up in the repo.
Yeah, correct. So Rob's asking, in case the audio is not fully coming through, if this is non-interactive. So you're not logging into this GitHub machine, you're not using SSH, you're just sending a script out to it and letting that script run and then storing the outputs. And that's correct. And I'll show a little bit more about what it looks like when it's running, because you can see the logs on GitHub's interface, but you're not actually logging into the machine.
Yeah.
Yeah. So the batch can come in, you can run workflows individually. So you design a workflow to just operate on a single image pair. And then a lot of batch systems are designed where you use environment variables to kind of dynamically map to a lot of different image pairs. And that's exactly how a GitHub design would work. So you can start layering workflows. In GitHub's terminology, these are called matrix jobs. So you run every possible combination in a matrix. And so for example, you can have two sets of images and you want to run every pairwise combination of processing in those images. And here is what this workflow looks like on the GitHub web interface. So this is mapping out, like I mentioned earlier, an entire year's worth of image processing. You see the entire logs for each action that runs, each workflow that runs. So the numbers here on the left-hand column are dates of different images. And then for any one of those dates, you can store outputs in what GitHub calls artifacts for the workflow. And that's cloud storage. That's object storage, where you have a zipped file that's stored for 90 days. And this is getting into what I mentioned earlier with the ephemeral outputs. This is great for sharing with a team. So any team that has access to the repository can access all of these outputs, but they are not stored indefinitely. So it's sort of set up to run, and then if you are satisfied with the results, it's up to you to download those or put those somewhere more persistent. And while a workflow is running, and for 90 days after, you have access to logs. So you see all the steps in the workflow, such as setting up a Python environment, running the script. You'd see outputs from each of those steps as they run. So you get feedback into the workflow as it's running through GitHub's web interface. There are access to GPU machines. So here is just a quick example of running workflow on a machine that has a NVIDIA T4 GPU. That's the only option currently, as far as I'm aware. But you can select to run the workflow on one of these GPU machines. So one other example that we have is to a project where we're running machine learning training script that use PyTorch, and it's much faster if you have a GPU to do that training. But for development, you're often just wanting to run things on the CPU because it's cheaper to see if it works. And so an option you can set up to run these workflows is among your inputs, like one of your dynamic inputs can be the machine type. So this is another example where one of our inputs here, it's called runner type. That can be anything you want, but we point to different machines. So this is great for testing where you run on the smaller machine and then you have the option to just change the machine, point it at a GPU machine. And finally, the other feature that GitHub offers that's different from Actions is what they call code spaces. And so this is a hosted machine that you do log into, to Rob's question earlier. This is basically a machine that has a VS Code installed on it. And it's linked to a repository. So any code repository you have, you have a little toggle on GitHub's interface to launch a code space, and it spins up a machine on Azure, copies your repository over, and opens a connection to VS Code. So you can use SSH to run everything on that machine. Again, by default, you have certain access for free, but it's a pretty small machine. I think the standard smallest machine they have is a 2-core machine. But through this setup, through this linking to a GitHub education account and linking to your Azure subscription, you have access to these much larger machines. So you can go up to a 32-core machine and use that. And so again, that's much bigger than what I currently have on my laptop. So it's nice to be able to just have the Azure subscription and use this stuff. It's also great for workshops, I should mention. So we've used this in the past to run X-ray workshops for hundreds of participants simultaneously, because each person, as long as you have a GitHub account, you can launch a code space, and that billing is can be handled in a centralized way where it's routed through a single account, or if you're doing lightweight stuff that doesn't require large machines, then everyone can launch kind of that 2-core base level machine on their own account. And I think it's 1,000, or no, I think it's 100 minutes free per month, 100 hours free per month, excuse me, that anyone with a GitHub account can use. So it's not a lot, but it is great for smaller workshops, in my opinion.
Quick question. If I'm using code spaces and I have this virtual machine that has a clone of my repo in it, if I manipulate that code space version of the repo, that doesn't affect the GitHub version of the repo.
No, so yeah, Rob's question here in the room was if you're connected to this code space, do changes to your code automatically appear in your GitHub repository? And no, they don't. It's like just going into a server somewhere, doing a local clone.
Right. So the git push would.
So yeah, and you can, what one nice thing about it is because it's all linked through GitHub, it automatically has your credentials, so you can just push the changes back. So it is really good for development. There are a lot of other use cases for this, using GitHub for various, I think, scientific tasks. So this is a list that I put together with a colleague, Valentina Staneva in eScience. We've used it for many things, such as interactive visualizations, where you can create a GitHub pages that's associated with a repository and automatically update data that's showing some visualization on a website. We use it for data validation, so running cron scripts like every night to make sure things are working properly. Or maybe setting up a system where different people commit different code that you could automatically test. Performance benchmarking, or again, kind of trying out new algorithms and looking at outputs together. So that list is actually from a workshop from the SciPy meeting back in 2024. And I've put a link for that if you want to go into more detail and see. It was a 4-hour workshop, so that can be nice if you're new to this to try out some of these I think alternative, fun, different uses of GitHub. And that's all I've got for everyone today.